This video is on rearranging literal equations. A literal equation is just a formula or equation using variables as placeholders. They include formulas such as the examples shown here, which are probably already familiar to you. We have slope-intercept form, y equals mx plus b. We have the area of a rectangle is equal to length times width. The formula to convert Celsius to Fahrenheit, and the distance formula, where distance is equal to rate times time. A lot of times we need to find the value of a variable that's not already sort of by itself in the formula. And so we need to be able to rearrange the formula to serve our purposes for a particular problem. In the example below, we're given an equation, or the formula, d equals r times t. And so we want to solve that equation for r. And to do that, we're going to follow the same rules that we always have for solving equations. It helps to box in what you want by itself. That way you keep your eye on where you're going. I see that there is a t next to the r. What operation is happening with the r and the t? Is it adding, subtracting, multiplying, or dividing? I hope you said that r and t are being multiplied, and of course the opposite of multiplication is division. Since I want to get rid of the t, that's what I'm going to divide by. But what I do to one side, I have to do to the other. So just as if it was a 3r, or if it was a 3r and you divided both sides by 3, we're doing the same thing, but with t. Notice that the same rules apply. Now, t over t cancels on this side, and in step 2, I have d over t is equal to r. r is by itself. What did I do to get there? Well, I divided. I divided both sides of the equation by t, and so my reason is the division property. Now, this was just one step, and sometimes if it's a short formula, it may be just that. Let's look at the next example, and in this case we're going to use the very familiar slope-intercept form of a line, y equals mx plus b. The instructions say solve for b, and so I want to take that and box the b in so that I keep my eye on the thing that I don't want to touch. I just want to get everything else away from the b. So here's my given. I can write given formula here. And I notice that this b is being added to mx. This is a positive mx. So keep in mind, since I'm not interested in moving the b, it does me no good to say let's minus b from both sides. But I can minus mx from both sides. And when I do that, it serves my purpose because positive mx minus mx cancels each other out. And on this side, on the left side of the equal sign, remember they're not like terms, you just write them, y minus mx equals, notice my equals did not change position. Those of you who are a fan can write the line down the center where the equal sign is. And I have b left on the right side of the equal sign. b is now by itself, and that's how you know you're done. Once the variable you're looking to isolate is alone on one side of the equal sign. What did you do to get here? Well, I see that I subtracted mx from both sides, and so that's the subtraction property. I want you to go ahead and look at the next example, and you'll see that it's the same equation, but this time the directions say to solve for m. And I want you to pause the video and go ahead and try to do that on your own now. So how did you do? So the highlighting is my steps, and since I wanted m by itself, you know that you have to wait to do division until the end, until there's nothing else that you possibly could do. So we want to get rid of this plus b. We subtracted b from both sides. Notice that y minus b. Those aren't numbers. You can't combine them. All you have to do is write them, y minus b. And you still have the m with the x that stayed since we subtracted subtraction property. Again, you're focusing on getting m by itself. X is being multiplied to the m, so you divide by x. And of course you have to do it to both sides. What you do to one side, you do to the other. Notice my big fraction bar with x underneath the whole thing, y minus b. So y minus b becomes my numerator, the top of the fraction, and x is the denominator, the bottom of the fraction. Over here with the m, x over x cancels, and that's how we got m by itself. We got there by dividing, so division property. I hope you did well. That's all there really is to this. You have to focus on a few things. Remember that rearranging formulas works the same as solving any other equation. We use inverse operations in the same way you always have. Keep your eye on your goal by boxing in the variable that you want to isolate. I know it may seem like a small thing, but it will help you if you do it. Remember, don't try to combine terms that aren't like. If you have y and then you take away or minus b on the same side of the equation, don't try to do something fancy. Those are not ones. They're not any number that we know. All you can do is write them. When you're not sure what to do next, ask yourself what you would do if there were numbers there instead of letters. What if there's a P in the formula and you don't know what to do with it? Ask yourself, what if that P was a 4? What would I do then? And you probably know what to do when it's a number. The rule doesn't change. Do the same thing when it's a letter. Good luck.